All right, so we live our entire lives on continents, right? But have you ever stopped to ask a really fundamental question about them? That's what we're going to dig into.
And yeah, why are they here at all? Because, when you really look at the basic geology of our planet, the land we just take for granted is actually a huge cosmic mystery. It's a feature that, by all simple logic, probably shouldn't even be here. So, what's going on?
Okay, here's the basic contradiction. Most of our planet's surface, and I'm talking the entire ocean floor, is made of this dark, dense volcanic rock called basalt. But the continents, the ground right under our feet, that's something else entirely.
And that, right there, is the heart of the puzzle. Continents are made of a much lighter, more buoyant type of rock. If our planet was just a simple, perfectly mixed molten ball that cooled down, we just wouldn't have these things. So there has to be some kind of mechanism that created this planetary anomaly. So the first clue to solving this mystery comes from a rule that's so simple, we see it absolutely everywhere. You can think of it as nature's own sorting hat, just deciding where everything belongs.
That's really it. It's just density. Heavy stuff sinks, light stuff floats. You've seen it a million times. Oil on water, a cork in a bathtub. It's a universal principle. And it turns out this super simple rule governs the entire structure of our world. So let's apply this to our planet's rocks. The basalt that makes up the ocean floor, it's dense. It's heavy stuff. But in contrast, the granitic rock that forms the core of our continents is light. It's naturally buoyant.
And this is so crucial. We need to stop thinking of continents as just the crust or the land. They are fundamentally different. They are the light, floating leftovers from some great planetary process. So if continents are the leftovers, what's the process that's sorting them out? Well, it turns out Earth doesn't try to make continents, it makes them completely by accident through a giant planetary filter. The scientific term for this is chemical distillation. And it's just like distilling spirits, You boil a liquid to separate the alcohol from the water. Well, Earth does the same thing, but with rock. It melts a mixture and just lets the light and heavy components separate themselves. So here's the geological recipe. First, the deep mantle melts to create that heavy, dense basalt of the ocean floor. Then, that oceanic crust gets pushed under another plate in a process we call subduction. It goes down, back into the heat where water helps it remelt. But this time, it's a partial melt. It's a distillation. The lighter, silica-rich bits separate and rise up, while the heavier iron and magnesium parts sink right back down into the mantle. Through this constant cycle of recycling and remelting, the lighter materials just froth up to the surface. Continents, then, are basically the geological foam that's been skimmed off the top of this planetary brew. Okay, so we've established that continents are the light, foamy leftovers. But that brings up another question, right? Why don't they just get recycled back into the mantle like the rest of the crust? And the answer, once again, comes right back down to density. The oceanic crust is dense, and it's relatively thin, so it sinks back into the mantle pretty easily. But continental crust is different. It's not just light, it's also incredibly thick. It's like trying to sink a giant, unsinkable aircraft carrier that's made out of styrofoam. It just can't be done. So the crucial takeaway here is that this is a one-way street. Once this light continental material is created, it's here for good. The planet's recycling system works for that dense basalt, but it has no mechanism at all to get rid of this buoyant continental crust. So what happens when these unsinkable landmasses collide? They can't go down, so they go up. The crust just crumples, it folds, and it thickens, creating the massive mountain ranges we see all over the world, like the Himalayas. You could say mountains are the geological scars of continents just refusing to be recycled. And because this is a one-way process, with every single cycle of subduction and distillation, a little more of that light foam gets added to the continents. They don't shrink, they slowly grow over billions and billions of years. In a way, they're a record of all the recycling that's ever happened. They really are Earth's memory. So now we have all the pieces. Let's put them together for the grand reveal, the deep insight that explains the whole thing. This just flips the whole idea on its head. We thought the question was, why does Earth make continents? But the real answer is that Earth isn't trying to make continents at all. It's trying to get rid of its dense, heavy rock by sending it down into the mantle. Continents are just the unintentional but permanent byproduct of that process. To really lock this in, let's use one final image. Forget all the complex geology and just picture a pot of boiling muddy water. What happens? The heavy stuff, the mud, it naturally sinks to the bottom. But the boiling action creates this light froth that gathers on the surface. Well, that's our planet's process in a nutshell. The continents we live on are simply Earth's chemical foam.
And that's the ultimate takeaway. That's the answer to our question. They are the buoyant residue, the light stuff that got filtered out and just couldn't be put back in, accumulating over billions of years into the landmasses that define our entire world. So I'll leave you with this thought. We just learned that the very ground we stand on isn't a primary feature, but an accidental consequence of a planetary sorting system. It makes you wonder, what else in our worlds, or maybe even in our own lives, exists not because it was intended, but because it's the inevitable residue of some other, deeper process?